So this is lesson 2 in radical and rational functions. One thing I noticed from the work I've seen over the last couple of years is it's very difficult to see the connections between function graphs and the square root of those function graphs unless you've practiced and played around with it. So there are actually 6 graphs to create here. They've graphed the original function, and we're looking to graph the square root function and get an idea of the domain and range of the original function, and then the domain and range of the square root function. I think it's valuable to use your calculator to record the results and to make a stab at domain and range. I'm going to draw my graphs, write out the domains and ranges, but we should take some time to practice that. So have at her, 6 graphs, 6 domains and ranges. Okay, after having been frustrated with my orientation, I can. How exciting is that? So I was to change the graph of an absolute value graph into the graph of its square root. So I hope you've been able to come up to these conclusions on square root graphs. If you turn the page over, we've got 2 more to look at. I do believe the practice is worth it, so try the next 2. Well, I've had to do a fair amount of work on your own, getting your calculator to graph square root graphs, hopefully recognizing the significance of not being able to square root a negative number. You can make some of the conclusions about domains being the same and what else is the same. We want to make some conclusions that are a little bit more overriding down below. So when does the graph of the square root of the function not exist? We end up with problems when the function generates y values that are less than 0. So we end up with problems there. If the function evaluated at x is equal to 0, then the graph of the square root of that function lies where? They're actually going to be the same point. Since the square root of 0 is 0. If the function, if the y value is between 0 and 1, the graph of the square root of that function lies. So we see some nice connections with square roots. If you're square rooting a y value between 0 and 1, you actually generate a larger value, which is why the graph was above. If you square root 1, that's still on the same original graph. But if your y values are greater than 1 and you square root them, you'll actually generate values that are smaller. So that's it for our generalizations. Let's try a couple. Some nice conclusions are made here when we're trying to build the graph of a square root graph from the graph of the original. So note these, practice these, see these in the work that we've done. When f at x or y is less than 0, the graph of the square root does not, the square root function does not exist because I can't square root a negative number. When f at x is equal to 0, then the square root of f at x is equal to 0. When f at x is equal to 1, then the square root of f of x is equal to 1, leading to invariant points, points that are the same on both graphs. Note that in some of the graphs that we've drawn already. When we're between 0 and 1 on the y, the graph of the square root of the function lies above. We talked about that already. When f at x is greater than 1 and I square root my y value, I'm actually going to go lower. It lies below the graph. And a few other nice conclusions and some things we'll play around with. 2 graphs to look at. So if I'm going to graph the square root of this graph, I do it as if I have become a chart person. I take a look at what's my potential table of values and know that the only thing that I'm going to change is I'm going to change the y value. The graph does not begin until I have y values that are positive. So when I look at my square roots, I take a look at square rooting from left to right. So trying to figure out my scale. The square root of 1 is 1, so that point is going to be there. The square root of 0 is 0, so that point is going to be there. The square root of a half, which is somewhere up that graph. What's the square root of a half? So I'm working through some square root ideas. I've got 3 points, and then I've got to take the square root of 2. The square root of 2 is not a particular nice number, but it's below. The square root of 2 is 1.41, so somewhere in that region. And then I'm going to go to the square root of 4, which is 2, which I can create a portion of my graph. So this curves and then goes straight, and then it goes straight all the way across. And then I've got to take square roots again all the way to 0. So I've made my way to the square root of 1, which is an invariant point. And then I have to square root a half, which is actually bigger than a half. So that's somewhere in here. So I get a little bit of a bulge out. And then I've got to make the graph go the other way. And then remember, the graph isn't going to go past 16. So I get some interesting arcs and straight line pieces. State the domain of the original graph. The original graph allows x to be anything. X is an element of the reals. The domain of my square root graph has been altered. The domain of my square root graph allows me to run from -3 up until 16, with x being an element of the reals. The range of my original graph, it went no higher than 4, but it was from -infinity to 4, with y, being an element of the reals. But as soon as I square root it, I lose all those negative values, and the highest value I got to was 2. So I'm going from 0 to 2 using that different notation system, 0 to 2 with square brackets, y being an element of the reals. Now, can I figure out domain and ranges without sketching the graph of the square root graph? So I'm trying to find or trying to study the square root graph. This is my graph, and I want to study the square root graph without graphing it. So they've defined h at x as being the square root of the shown graph. Well, we've seen the effect of domain and range. And this graph has nothing in the negative area for y, so I'm not going to have any trouble square rooting. Y and x will still be permissible along any value. X will be an element of the reals. I can see that my x goes on forever. I do take a look at my minimum value. It doesn't go below 3 on the regular graph, which means when I look at the square root graph, y will be greater than or equal to the square root of 3. And taking a look at the second graph that we have, I end up having to disregard anything that has a negative y value. So my x's look like they can go from, and remember, look at those endpoints, they're not lines. So my x's can go from a square bracket of -3 to -2, and then I can't use x values until I hit 3 to 8. So those are my only possibilities for x. X can run from -3 to 2, and then from 3 to 8. What happens to my y values? Remember, my y values are going to get square rooted, so they're going to get reduced. Y is going to be greater than 0, but no more than 9, the square root of 9. So y will be greater than or equal to a 0, but less than or equal to the square root of 3. I should write that the other way. Y will be greater than or equal to 0, but less than or equal to the square root of 9, which is 3. So my Y values run from 0 to 3. That's it for lesson 1 and 2 on radical and rational functions. That should be enough work, along with keeping up with getting ready for our next test to keep today active. Thank you.